Thank you so much for your introduction. I really appreciate that. I know the timing, let's say 8:16. I can see. So I'm between you. Between means I'm between you and your dinner. If you had, you if you didn't have so far, and if you had, then I I'm between your dinner and then before your sleep time. So I'll try to keep it light. And then I know you come from the academia. It's really my pleasure to be part of this session, and I'll try to give you the perspective, from the global perspective, and which can help in your role to prepare the future engineers. Okay, so with that, I will share my screen. Just let me know when you can see my screen.
Yes, sir.
Please confirm once you can see.
Yes, sir. Yes, sir. Screen is clear, sir.
Okay, once again, thank you so much for having me here. And then, as I said, that I will try to keep it light and simple. So let me get started. So my topic is reversing a power system with advanced technologies for the maximum efficiency. So two things I would like to cover. One is that the evolving energy landscape and what the challenge it's posing towards us, and then what are the emerging technologies and its application in the power system. So let me see if I can hide panel so that it doesn't cover my presentation. No. Okay. Okay, so what is happening now? So in this figure, you can see, uh, I know that you all know, but just to give you the context and the perspective here. So the top line shows, the traditional or conventional scenario where you have a unidirectional power flow, large scale generation, big transmission line, and then the local distribution, and then end consumer and industries. Okay, so that was the few years back story. But what is happening today? So now you can see around you homes with the solar panel, large storage for the peak saving purpose. Not so much popular in India, but if you go to Europe or the other developed nation, they started deploying the large battery storage for the peak saving purpose. And then EV, I think in the previous session also you have heard about that. So what is happening from conventional to emerging scenarios? So from a unidirectional, now we have distributed energy resources around us. A lot of the renewable energy generation is happening, whether it's wind, solar, anything. A lot of development is happening around that. A lot of local battery storage deployment is also happening. And I will also talk about something like the energy communities concept, which is getting popular in Europe and then in the Americas. Basically, smart homes is also coming. So smart home is not only about the video surveillance, but also from the energy perspective, how we are looking for from the energy perspective, you want to be smart. Okay, so this is the things which is happening around us. And you also heard about this net zero, uh, means the greenhouse which we are emitting, and then how we can absorb it. Okay, so net to net. Just to give you a simple example, suppose my energy consumption 50% if I am buying from the grid or the discom distribution company, and 50% if I have my own generation. It means I am net zero, just in a simple term. Okay, and there are different ways of generating these greenhouse gases. So and then I think you would have heard COP26, COP28, uh, and then every country is committing. Uh, they have their own target by when they want to achieve this net zero. India is also committed towards that initiative, and then different countries are in the different stages in that way. So what will happen? So now we see a lot of distribution energy, EVs are coming, and then countries are also committed towards the net zero. So what will happen? It means more and more renewable energy will come into the picture, and then as an individual you are also committed towards the sustainability. So then, of course, as an individual, you would also like to move towards, the LCTs are the low carbon technologies. It could be solar, it could be wind, it could be anything, EV, anything. So as an individual, we are also now more and more committed towards sustainable world. So this also will be coming. So growing concern about the sustainability and need for the grid modernization. So earlier, now you also see that a lot of the loads are getting added in terms of like the EV is also load. Uh, so and then you cannot predict when they are going to connect, when they are going to charge. So so it means and then apart from EV, a lot of other gadgets or anything, any new more and more components are being added at our home. So these are the the typical scenarios how world is moving. As I was saying, I'm in the next slide about the smart home. So smart home in terms of energy. So suppose you or myself, I have aspiration to move toward the LCT, the low carbon technologies. So I will have a different component at my home. I can have the solar panels, I can have the batteries, because I want a energy independence. So I can also put batteries so that I have minimum dependency on the discom or the on the grid. I can have EVs, electrical vehicle, and then last two is not so much in the context of India, but if you go to Europe or any cold countries or very hot countries, then you can find the heat energy storage or the heat pump concept. So what happens there? Uh, there either you can have your own heat generation method, which is quite popular in the UK and then the southern part of the Europe. But if you go to the upper part of the Europe or the Nordic countries, you will find the district heating concept. So there, centrally heat is produced, means the water is heated and then it's given or it's distributed around the city. And in the house, you will find, a unit where this hot water circulates and then they do the, the space heating. So another thing is coming like when I'm having the excess energy. I was also following the previous lesson where there was concern that we don't have so much non-conventional energy sources at the moment. But if you go to the Western world where they have a lot of renewables, or uh, or the LCT technologies deployed there, and then what they want to do, suppose in the day during the daytime when I'm having the ample amount of the solar and then energy, electrical energy produced, what can I do? Can I store the energy in forms of heated water which I can consume for my domestic hot water consumption? Like that, heat pump is another concept which is coming. So as a smart home, for the energy efficiency perspective, what I want to achieve, I want to consume the solar energy which I produced myself, and then of course I also want to get the electricity bill reduction. So this is like a smart home for the energy efficiency context. So now you see that this is the evolving energy landscape where centralized to distributed generation is happening. We have the net zero target. There are the smart homes coming. Aging infrastructure is an issue. Distributed energy resources are coming. As I also talked about, we have the battery storage are also coming. EVs are coming. So ultimately, it poses a challenge, for the electrical energy or the power system community that how to handle, this problem, because whether you say the solar or you say the wind, you cannot, guarantee that up to what level of efficiency or up to what level of generation will be happening. It depends upon a lot of other factors, natural phenomena and things like that. And once, as I was talking about the smart home or smart grid concept, when you have more and more connectivity, then also you have the cybersecurity risk. Okay, so these are the evolving energy landscape as a whole in the power system, and these are the key challenges. I'm in the next slide. This slide talks about the invariability. Okay, so I think you might be knowing this about the duck curve. It's very interesting. You can see from left to right when the day happens, sun shines, and then the sunset happens. So how the solar, the power generation, it goes up and then it goes down. and when it goes up, so this line shows how much, what is the net energy demand. And then if you read the middle line where we have put, means where you can read the years like 2019, 20, 22, and then when you grow, means how the time scale when you go down, how the net zero demand going down, because we are adding more and more solar generation. So in the daytime, I'm getting good amount of solar generation happening, and then overall the net demand for the power reduces. So how to handle that? How means how to store the excess solar power which has been generated. Okay, and do we have a good alternatives to store? We have the batteries, uh, but it's not so expensive. But it's not so cheap. It's expensive. And what could be other form of sources so that we can store this energy which has been produced during the midday of the time. And then this is the interesting thing, energy communities. I'm not sure whether you would have heard, but this is also getting very popular in Europe. So there as a community, like first I talked about as an individual, what is my aspiration, moving toward the LCT or the low carbon technologies. But we can also think as a community. Let's say in my area, we have 10 houses, and then some are having solar panels, some are not having the solar panel. But together we decide that, we want to bring down, our dependency, or we want to bring it down our energy purchase from the discom. So rather than sending it back or selling to grid, how we can effectively distribute this. So in the right hand picture, you can see that there is a main grid. So this is the physical connection, electrical connection between the houses and then the grid. But as a community, there could be like a contractual flow. So let's say I'm in house A, you are in the house B, and during the daytime I am having ample solar power, and I'm not is using at my home, but maybe in your house you can use it for some other purposes. Okay, so we have a kind of mutual agreement between you and me, and then uh, we can get benefit out of that. So in place of you are buying electricity from the grid at the higher rate, because if I try to sell this excess solar power to grid, I cannot get the same financial benefit. So I would share with you. Okay, so in the similar manner, this can be done in the community level, and this is getting very popular. And then as a community now, they are producing, they are sharing, they are consuming. Ultimately, they try to how they can how can they lower their cost. They can promote the sustainability. So this is also getting popular more and more in the Europe and then US, I would say. So basically, ultimately, what they want to do, they want to save through collective self consumption. And in some cases, like I have given the example for the France, since I am not utilizing the transmission network, I also get the financial benefit out of that, because now as a community, for the whole community, we are sharing this access power, or the and then we are not utilizing the transmission network capacity. So in that way, I'm also getting the financial benefit. So this is also getting very popular, this energy community concept. Uh, but it also has a challenge, how to do interoperable, how to do, the financial transaction in the real time, how to make it more secure, scalable, and then in some cases, energy storage is also coming, and then how to do, optimization in the dynamic way. So this is getting popular, but it also has a challenge. And of course, there are several companies and then even a startup who is providing solution in this problem space. And then I am the next slide. So this slide tells you about how many energy communities are there. This could be a bit old information, but you can see the Germany is leading in that way. Then Netherlands, Denmark, Ireland, Austria, France. So several European countries, you can see that how this energy community concept is getting popular. And then there are policies or framework is also coming. They get also funding in a different form, like the energy efficiency and then climate change adoption and things like that. So they're getting a policy support, financial support, to create more and more energy communities. I'm just keeping tap on the clock so that I should not run out of the time. So up to that, I talked about what is happening around the world in terms of power system. So bottom line is that we are moving from centralized to decentralized. Uh, Smart homes are coming, energy communities are coming, EVs are coming, and then batteries are also coming. I will also talk about that, how in Europe they use for the peak load as saving purpose. So these are the things which are coming, and it's not so easy to handle or to manage this overall. So this is the overall the space, power system space. Now let's look into the technology aspect and then sum up its application in the power system perspective. If you have any questions so far, please feel free to ask. Otherwise, I can take the question at the end also. All good so far? I don't know whether all slept or are you still awake?
You can continue.
Okay.
We will keep question answer session at the end of this.
Okay. Good. ठीक है. So let's continue. So some of the emerging technology which is known to you, nothing new I'm going to tell you, but I'll just try to give you perspective, some application which you can think of. And as I said that this can also help to prepare in the future ready engineers when they come to the industry for the work. So one very known is that smart grids, I would say intelligent grid in future. And then the below layer is about about the IoT and then connected system, energy storage, AI ML learnings, blockchain. This is a very good example I will try to give you in the energy community context, how this can be used, and also some advancement in the semiconductor domain which is shaping up. So let's get going. Smart grid. So as I said that about the problem space. So from traditional to uh, centralized to decentralized, and as I said that it's not so easy to handle because we have to handle in the real time basis. Okay, so what is required to manage this in the real time basis? Basically, you need the real time data, right? So you need to have a good connectivity. You need the component which are smart, means we earlier had, or we are still having the components which are intelligent, but they have to be communicate. Okay, so they have to provide the data to the upper layer. So you need to have the component which can provide the data. They have to be smart, and then you also need a two-way communication. Why you need a two-way communication? Because you want to control in the real-time basis. Just to give an example in a very simple term, suppose in the daytime when the solar energy is abundant, and now I want to communicate to my consumer that now so we have the ample amount of the solar power, and then we can offer you in the cheaper price, so you can use it for your heat energy storage, or if you want to charge your vehicle, you can charge with the lower rates. So you need to have communication in the both the directions. So not only getting the data, but also to communicate to your consumer, to act fast. You also want to have this communication to control the devices. Okay, and then of course automation. So suppose some abnormality happen, so we have to act fast, we have to resolve, and then we have to reduce the downtime so that the availability remains there. Renewable integration. So we have to find the balances due to the intermittent renewable energy sources with the demand. So that is also very important. And demand response, that is very critical component. Many utilities around the world, they are facing this challenge because the install capacity is not a challenge. Even in the previous session, you would have heard about that. So every country, or even in a country, if you look at the country as India, we have more than enough, the install capacity. So install capacity is not a challenge. But what is the challenge? The demand response. So when I have to turn on or when I have to use which source of energy. And then to make this happen, what you want? You want a real-time data. You need a good prediction mechanism based on the different factor. There could be several factors based on the season of the month, based on the festivity season or things like that. And you should be able to predict your demand adequately. You should be able to predict your renewable energy appropriately. So based on the based on the tomorrow, how the weather is going to be, and then how much production can happen, and then accordingly you have to think about that which are the the conventional power sources which I have to use, whether it's thermal or any other source of the power. So basically, you have to do in the real time basis. You have to have a good, the demand prediction mechanism, and then energy storage. So adding, the renewable energy more and more. So though you have added, but at the point of time when you have the good generation from this renewable energy sources, how to store it so that we don't waste it, uh, and then we should be able to use it when it is required. So that is about the energy storage. So uh, so a smart grid perspective, I have, in my whole power system from generation, transmission, and distribution, I have the capability to get the real-time data. I have the two-way communication to talk to devices, whether it's passing the messages or doing the control of those things, having the good automation system, good renewable integration. I have a good, demand response, good energy storage. It means that my grid is smart. It's able to handle the things what it has to do. And then if you add, the AI ML layer, then basically you are making your grid more intelligent because it's able to predict and then give you advice also that what you should do in the real time basis. I think that will also happen in the near future. Okay, so going forward, so as we already talked about, the IoT, why you need we need the data in the real time basis, and once I have the data, then I can do a lot of things out of that. Suppose I have a transformer data, what is the temperature, what is the voltage, current, and then different other parameters. So I should be able to do the predictive maintenance. So going from the traditional maintenance practices like I'm also using the car, as you also having some vehicles. So in place of doing my car maintenance at 10,000 kilometer or after running 6 months, if I know whether my car is really required maintenance or not, if I have such a mechanism, then it will be better, right? Because maybe I can wait 2 more months. I don't have to do the maintenance now. In the same way, because these are the critical assets, these are the very costly assets, and even to maintain those assets, it's very expensive, right? So how we can do, the predictive maintenance? So rather than maybe, for example, if my car is not in good condition, maybe before 6 months or before 10,000 kilometers, it can break down. So maybe I need maintenance before that, not like a typical time-based or the usage-based maintenance. So if we have the critical information about our assets, power system assets, and then if we can predict when exactly it's going to fail, and then I can prioritize my the maintenance of that assets in that manner. Even we can go to the next level. So let's say a utility, they hire a company to do a maintenance for any transformer. But what is the mechanism to close loop, whether the maintenance has been done or not? Because utility pay the money to vendor to do the maintenance. Maybe they are going changing oil and things like that. But whether the assets performance has been changed, how will you assess that? But if you are capturing your the critical parameter, And then if you can see, yeah, when the maintenance is done, the performance or the parameter of the transformer or the any critical assets has been changed. Okay, in that way you can do. You can go to the next level further. So how you can go to the next level further? Suppose if I'm maintaining the record in the digital form, okay, when this happened, what the action was taken, where it was a real problem, or it was the false alarm and things like that. And if I'm capturing this information, so next time, suppose a similar problem happens, if my system is able to tell me, okay, this is the problem now, and then this could be your probable solution. Means maybe based on the historical data, it can suggest me that you don't have to do these things, but you can solve this by these things. So these are the things you can go from the predictive to prescriptive maintenance in that way. So if you have the data, so you can do a lot of things with that data. And then if from the household or from the home or from the industrial consumer perspective, if you have the smart metering, and then you get the empowerment that you have the control of how much consumption is happening, what is driving. Like I was showing you in the previous example of the smart homes. So if you have your usage pattern, and then how you're effectively utilizing your resources in that way, then you are empowered, because now you know how things are happening, and then how you can control the things. So of course, the IoT brings a lot of the advantage, because as we say that data will be oil for the future, and of course not future now, that future is now, because uh, previously communication was a challenge, but you can see now with the 4G, LoRaWAN, NB-IoT, a lot of communication technologies, even your a lot of mesh communication technologies. So that is not a challenge. So data transfer, whether it's small, bulky, that's not a challenge. So you can easily get the data, and with the data you can do the magic. Okay. So with the data acquisition, and then with that information, you can do a lot of you can put a lot of tech stack on top of that, AI, ML, whatever you give the name, blockchain, whatever you put the name, and then you can do a lot of things using that data. So as I was speaking, just to give you a context that how you can use AI/ML in the maintenance. So this is the Gartner chart, and the left part shows the maturity model in the maintenance. So like run to failure, time based, uses based. As I was telling you, this is the typical the method which we use, but we can go to the next level, condition based. So if I'm having the data, and if I know that my assets condition is deteriorating, I can prioritize, I can do maintenance now. I will not wait that the 6 months is not over, or this much kilometers my vehicle has not run. And I can go to the next level, that is the predictive maintenance. Then I can go to the further level of reliability centered, and then further level of the financial optimization. So these are the the look into this maturity model for the maintenance. And the right hand side picture shows that how much human intervention is required when you go to this maturity level. More and more you use the data, the more and more you use AI/ML, the less and less the human interventions is required in the decision making process. And then this also solves the problem. In many of the countries, they're also struggling with the aging workforce, where the next generation means this is a transition stage in terms of workforce. So how to speed up, or how to speed this learning curve. So I think this database approach, this also solves that problem. This I just give you the example, give you the perspective. Like that, many more things can be done in the power system perspective. Uh, you can see there is a list of things which you can do. You can do the state estimation, predictive analytics, uh, demand forecasting. Means if you have the data, right, then you can do magic with that. So lot of tasks which are done manually, correlating the data, getting you the insight with that data. But with the data actually, and with your IoT connectivity, because now now the devices are more and more smart, they can communicate. Computing is not a problem, communication is not an issue. So with that, actually, a lot of things can be done. And then you name the industry, you name the area. I think AI, ML, or this can be applied in many area. Even in the secure, we have many solutions where we are using AI, ML. For example, we are working with the European utilities for their demand forecasting. In the real time, in the real time basis, we do the load flow analysis. Um, we do the prediction how it's going to happen based on the historical data and things like that. Like that means I come from the Siemens, I come from the ABB background, and then I know that a lot of solutions are being developed using the AML in the power system, not only the power system, but any other domain, like the whether it's a digital industries or the industrial automation domain. So, uh, so this is really flourishing. It's really helping, as a end customer, as a user also. You name the area, you will find some other application using the AIML. So this is really growing very, very fast, very well, I would say. Now I am in the next slide. So yeah, so I was talking about the energy storage, how this is used in Europe, and it can be used anywhere. So this is done basically at the distribution grid level, I would say. Suppose uh, suppose we have a limit, right? That okay, this is my limit. I said that I will not go beyond this much power demand. So what can I do? So suppose when my as a suppose I'm industry A, and then suppose this is my limit here, and then when my consumption is low, what can I do? I can charge my batteries. I can store energy. Let's say I'm storing as a heat energy. I can run any non-critical load. So that could be my strategy as a industry A. And what should I do when my energy demand goes up? Of course, at that point of time, in place of buying, the high cost energy, because there are penalties and things like that. If I'm shooting my limit, I can turn it to my battery storage. So I can use my battery storage to make the peak power demand, right? And I can also, and then as I was telling that if you have the IoT connectivity to a communication, then maybe I can shift my non-critical load to some other time. So I should be able to shift. So I have automation done as a smart grid concept. So I have a good communication, IoT, good automation level. I should be able to shift my non-critical load to some other time zone. Okay, so in place of using those non-critical load here, maybe I can use somewhere some other time frame. I can use here, I can use here, and then as I was telling you that I can encourage. Suppose I'm running a utility. I'm a discom company. I can offer time of use tariff, and then I can encourage to shift the load so that they should not run load at the same time in the peak load time. So these are the typical things which can be done. And suppose if I'm having some power purchase agreement with their distributed energy resources or the virtual power plant, so I can also do that. Could be also my strategy. So at last, cut load as per the priority. Suppose all this my strategy gets fail, then of course I have to cut my load, but that should be last resort, and no one usually prefer to do that. But this is just as a concept I'm telling you. So so this is the use, where the say, energy is used, and then of course it depends upon how much capacity you have deployed for the for the energy storage. Suppose this graph shows that if I look into whole year my energy consumption pattern, so how much I want to save. So suppose I want to save this part, then of course I have to add this much storage capacity. Suppose I want to save from here to top to bottom, then of course I have to have the higher storage capacity. It could be battery or something else, but yeah, you need that much storage capacity to shift your peak load. And then this is also growing very much. There are several examples. Like I have given one example in Germany, there is a grid booster project with 250 megawatt batteries stabilizer renewable energy flow. So it's not only about for your peak load saving in terms of financial, but also to manage invariability because of renewable resources. So they try to manage this invariability using battery storage systems. So these are the simply I gave you one example, but if you browse and then if you try to search, you will figure out several examples around that where in the world uh, energy stores are being added for invariability handle, peak load saving, and things like that. Yeah, this is very interesting example. Maybe good. This could be a good product or the solution which where your college students or you can think of developing. So it was the similar line which I was telling you in the energy community concept. So if I have the if I want to apply the blockchain uh, in this context. So suppose I have a blockchain supported meters, okay, and then we are in energy community. We are sharing resources. So if I'm having surplus power, I'm sharing with you. If you have the surplus power, you're sharing with me. And even if I don't have the energy, renewable energy, but if I'm part of your community, then of course I'm also sharing when you are having the surplus power. So in the right hand side, you can see, suppose there is a red line is nothing but the power tariff from the grid or the discom company. But as a community, we can have the below layer, because as a community we are not buying power from the utility, but rather we are sharing among each other. But what benefit as a community we are getting? Because if I'm an individual, I'm having surplus power. When I'm selling to utility, I'm not getting that much tariff or the price from the utility. But when I'm sharing with you, then this red line becomes a green line basically. So that becomes the local energy community price. So this is just a concept which I read. I found really interesting, but I think this will be the reality in future. And then I think this will be a good area for exploration or the further research, I would say. So now, yeah, this is on the semiconductor part. There is also evolution happening in the semiconductor area. Wide band gap. There is, you can read the name, silicon carbide and the gallium nitride. These are the some materials which are coming, and with that actually material, you can operate at the higher voltage temperatures uh, with the lower losses. Faster switching can be done, and then you can do this better thermal management. You get the better power density, and with that actually you also know that HVDC is also getting very popular to evacuate the bulk power, where uh, let's say where you have the wind farms quite away, and then you have to evacuate power from there, and then you have to bring to the mainland where people are living there. So this is also, HVDC is also very good technology. It's also getting more traction, more install bases coming in India, around the world as well. And I think these technologies can also help to overall optimize to have this energy efficient solution around that. So now I come to the last. So just to have a recap. So what did we learn? So we learned about how this energy landscape is evolving from centralized to distributed generation, net zero target, uh, solar, EV, energy storage, and things like that. We also talked about the emerging trends technologies, which is getting mature because it's not something new which has emerged now, but it's but it's existent, but it's getting more and more mature and more intelligent. So smart grid, IoT, connectivity, energy storage, AIML, blockchain, and then something on the semiconductor part. We also touch base upon that. So if you look into that, how this global, what's the global trend and what are the different opportunities which are coming. So basically, expansion of the decentralized microgrid, as I gave you the example, simple example of the energy community. So this is also like a smart microgrid that is going to happen more and more. And then we also know that global shift toward the electrification of transportation. So we only hear more in India from the EV perspective, but I was reading yesterday that in Sweden they have created a road track where when you're driving your vehicle, it will be automatically charging. So this is happening. This is going to happen more and more because as a individual, as a as a citizen, we are also committed towards on the sustainability goal. So this is going to happen more and more. Green hydrogen as a key solution for the long-term sustainable energy storage. Of course, this is also happening, but not so cost-effective. I would say a lot of innovation is happening. It's maybe like the battery, it could be reality. We'll have the more and more install base. But yeah, this is evolving. And as you see that, like the smart home energy community, it requires policy framework, and then of course. So that is also area where policymakers are working. In Europe, as I said, that even for the energy communities, a lot of policies, investment funding are given, and in the global scale also we need international cooperation so that together as a world we should be able to achieve our net zero target. So with that, I will stop. Thank you so much for having me here and then listening me. Please feel free to ask me any question if you have now. And then if you have some question and if you would like to connect me with me later, you are most welcome. My mail ID, my phone number is given here. Thank you so much.
Uh, Thank you so much, sir. Thank you so much. On behalf of everyone present.
Maruf,
Ji,
just a
sir.
minute.
Ji, sir. Thank you.
If anyone has any question, you can raise your hand.
Yeah. Rana Stick Singh has raised a hand. Yes, please feel free.
Please unmute.
Sir,
So,
uh, good evening, sir.
good evening.
Sir, actually, I would like to know how are we implementing IoT based? Actually, these are the things we are understanding that the IoT and blockchain and also we are implementing. But these are on the paper we are understanding. But what are the ground level? I mean, implementation regarding this. How can if I have to understand regarding the IoT implementation or blockchain, then what I need to go into deep dive into these things so that I can understand about it about these things. On the paper, I'm understanding that this is a blockchain and all we have to apply for the the system or IoT based system. But if I have to move further in the advanced level, that how I have to implement, then what should I do to understand it much more better, or I can understand it in a practical way.
Okay. So I'll give you very simple example. Okay. So in India, we have the distribution transformer, right? You would have seen distribution transformer in very bad situation hanging here and there, you know. And in India, we have around 20% failure of the distribution transformer. Okay. 15 to 20% in India. But if you look into a global trend, it will be around 2 to 3% where the distribution transformer fails. So now, if you look into that distribution transformer, there is no connectivity, there is no monitoring of that. So what can you do? If you can develop very simple solution, which by which utility get the information, what is the situation of my distribution transformer, whether it's overloaded, underloaded, it's running on the capacity, it's running under the lower the capacity, or it's running over the capacity. If you can predict that when this is going to blow, this transformer is going to fail, that becomes your IoT use case for the distribution transformer. How can you do? You can measure the voltage and current. You can measure the temperature. You can put some communication technology on top of that. You can put cellular, NB-IoT, anything. Now the NB-IoT is also offered by Airtel. And just communicate, bring the data into the cloud or anywhere, edge, and then do the computation, give the prediction. That how let's say I'm a utility A and then I'm having 2000 my distribution transformer fleet. If you are able to tell that out of 2000 your 500 are running less than the other capacity, 100 are running more than the capacity, and then if you can recommend that, hey utility, if you can shift your high rated transformer from this position to this position, because here you have put the high rated but the load is it's running only on the 30-40% of capacity. So this becomes a use case, how you can apply the technology and then help the consumer. I just gave a very simple example, and this is actually a practical problem in terms of India. Blockchain, how to use the blockchain, what is the advantage of the blockchain? Because you can no one can tamper the data, right? That is the advantage. I can give you the example. Suppose as a utility I'm buying some renewable power, okay, but how will I ensure that what I'm buying it's a true renewable power? or as a regulatory, suppose you are sitting in Delhi and you are a regulator, how will you ensure that what you are saying it's a true, it's a fact actually, and then it's a non-negotiable, non-tempered data. So that could be a use case. I'm just taking the example from the power sector or the power system perspective, but I can give you other example from the other industry perspective. But this is how you can apply the technology and then get the benefit out of that. So think about that whenever you're thinking. Look at some use case and then think that what technologies can be deployed around that. Does this answer your question?
Yes, but I mean, for the implementing this thing, like the if I have to put some communication technology, I mean, instrument over the transformers and all, so that will be, I mean, and the chip for the communication purpose, so that will be very much costlier. I mean, if can we implement on the ground level, because there, if in the, suppose I'm in Delhi and we have, suppose here, 4 to 5 thousand transformers, I mean,
I just
distribution
gave you
transformers.
example. You don't have to take in the literal manner. I just gave you perspective that you can think of any example in that way. So think about that. Any power system scenario where this can be used. Other scenario, suppose you have the ring main unit, right? You have the RMUs there, and
Yes,
then
sir.
you have some component, which maybe some of the component maybe that cannot withstand with that high level of temperature. Let's say you're in Delhi, it's in the panel. There is no a good ventilation, but maybe because of that some components are getting failed. So you can think of that, okay, based on the weather forecast prediction, and then you can develop some model, and then you can, if you are able to predict, yeah, the temperature is going up, and then since there is no ventilation, this may create dangerous, for the component which are deployed there. Anything which you can think of where this technology can help. Of course, it has to go through the ROI, means cost benefit analysis. But think about that, the application perspective, rather than as an academic or as an engineer, we always think that first think about the technology and then try to fit into the application. But it's other way around. We have to see what's the problem, how big is this problem, and then think about that. Whether this is really cost effective, whether it's really solving that problem. So think in that way, think about the application, and then think about the technology, whether this is fitting or not fitting. Okay, we have other one, Kishore. Yes, Kishore, please.
Sir, good evening to all of you, sir. My
evening.
question is that in India, we are having the more energy losses up to 33%. What is your perspective on this energy consumption and sustainability in the electrical field?
So where is this loss? It's in the transmission, or it's AT&C
Transmission
losses?
Transmission losses are there.
Okay. So yeah. So what can you do to reduce the transmission losses? Now, since you are all from the electrical or the engineering background, coming academia, so this is the problem space, right? You are saying that there are transmission losses. What can we do? What can we do to reduce the transmission losses? Even in the discom, there are the other type of losses, AT&C other losses. So for the
I am from civil engineering field, sir.
Okay. You come from the civil engineering
field.
Okay.
But I have this question, and I am asking for the solution.
So okay. So traditionally we used to have this three-phase in very simple language transmission network, but you would have also heard about the HVDC, which I was explaining you, which could be more efficient because there is no frequency involved, less less losses in that way. I would say I'm trying to in very simple way. Maybe other electrical engineer can help you, but since you come from the civil engineering background, just to give you the perspective, there are other technologies in terms of transformer which are coming up, and then which will be much more in terms of losses and things like that, which is more effective, like the HVDC and things like that. But in terms of discom losses, because the distribution company also goes through major losses, it's not always about the transmission, it's also about the commercial losses. And that's why you would hear about, a lot of AMSP, basically advanced metering infrastructure projects, where they want to monitor, how much at the distribution transformer level, how much, energy they are supplying, and then how much they are able to, get from the billing system from the customers, so that they can figure out where exactly the problem is, because discoms are running, means they're running, the losses, financial losses. So in that way, central government is running that project, to bring the transparency to the system. Some state has gone ahead where they are also, controlling the electricity supply, because like in the Bihar, where my company has done the project, prepayment meter, where they also cut the power if you're not paying your bill. So like you are doing recharge for your mobile, you are also recharging your electricity meter. So that is also happening, and this is not only happening in India, but it is also happening around the world, just to manage that.
Any more question? Okay, Ashish, since you have a vast experience working with ABB and Siemens, so I just want to ask you, the electricity is most convenient mean of transmitting the energy. But biggest disadvantage of this is we cannot store it. So I just wanted to know what where the industry is going to uh, to store bulk energy, or to devise a new technology with the help of which we can store a large amount of energy. Uh,
Yeah. You see, what I see, what is happening today, and then what will happen in the future. That's the future basically. But what is happening in the developed country, that I can say, uh, they are one thing is that battery, everyone knows that a lot of battery energy deployment is happening around the world, I would say. Second thing, in the home like level, or the community level, what they're trying to do, is store the excess energy whenever they're having. They try to store in some other form. Let's say heat energy storage. So, like in the Western world, where they need also, the hot water for the domestic purpose. So, whenever I'm having the excess power, if I can, translate this electric energy when I'm having, in abundance, which I wouldn't have consumed, if I can, preheat or the heat my water, which I can use for the heating purpose, which I can use uh, for my domestic hot water purpose. These are the practical things which are happening. But I also hear a lot of things about, uh, like the hydrogen and, nuclear and blah 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 blah. But I don't see anything which is happening in the reality, at least next 4 to 5 years, because we work with the several utilities around the world, and then what the solution they are looking for, they are looking around this area, means uh, how we can, manage efficiently the resources, and what are the available technology which is accessible to us. Other things are still in the research phase, I would say, not commercially, deployed in that way. So this I'm giving you a very practical, simple example.
okay, thank you, Ashish. So I don't think anyone has any question. So Maruf, if you have to say anything.
Thank you, sir. Uh, Thank you for your valuable words. Mm.
So good. Thank you so much to all. If you have any time, if you'd like to have any conversation in any time, please feel free to connect with me. It will be my pleasure to, to have engagement. and conversation around these topics. Thank you so much, and good night to you all.
Thank
Thank
you,
you, sir.
Ashish. Looking forward to meet you someday.
Sure.
Okay, so let us call this a day. So good night to everyone. So I will end the meeting now. Thank you.
Thank you, sir. Good night.
Okay, one last thing. Tomorrow I will start meeting at 5:30 p.m. So if anyone has any question regarding process, about feedback, about assessment, about attendance, they can join and ask those questions at that time. So tomorrow I will open the meeting at 5:30 p.m. Thank you.
Okay, sir.